Okay, this is your next lesson. This is actually lesson 1.5. Um, we're going to go back to 1.4 on Friday, which is just a review of word problems, and do that together as a fun activity. But today with 1.5, or I should say for tomorrow when you get here, your objective is right up top here. What we're going to do is describe a function and express it as an equation and connect functions to real-world situations. Okay, so let's go over quickly kind of what you remember about what a function is. A function is a rule that pairs each input with only one output. Functions can be shown in different ways. The table of input and output values at the right is one way to show a function. So they're talking about this one right here. The real rule for the function table is add 3 because every output is 3 more than its input. You can also write an equation as shown below the table. Write the output for the last row. Okay, so what they're telling you here is we have, with functions, you have one certain function for a table, and that function applies to all of your inputs, and you'll notice it in your output. So the function here is adding 3. So when you put 0 in, you add 3 to it, and 3 is the output. 1 is your input, add the rule 3, and you have 4. 2 goes in, 5 comes out. I always remember functions because unfortunately when I was in elementary school I didn't know anything about functions or function tables. It wasn't something that we talked about. So it wasn't until college that it was brought up. But I always kind of think of this function machine. Okay, little machine, you're going to put a number in the top. Something is going to happen to that number, and then a new number is going to come out. So right here you have your in and you have your out. Okay. So if our rule is like this function table that we're adding 3, we're going to put a number in, add 3 to it, and then out comes that new number. So kind of a fun little way to visualize it in your head. So when you put 5 in, you drop 5 in, think of some fun noises, boop, 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 plus 3, and out comes 8. Okay, 5 goes in, and out comes 8. So if we were to take that 9 and put 9 into our function machine, 9's going to go in, drops in, you add 3 to it, and out comes what number? 12. So when they talk about an expression or an equation to represent that, we have the variable, and they have this being an I, but to me it looks like an L, so I'm going to make it a capital I. You have your input, or I, plus 3 equals your output. That's not a 0. So input plus your rule, 3, equals your output. And instead of writing input and output, we change that variable to I and to O. So let's go down here and look at some function tables. So number 1, what we have is we have our rule already told to us. So the rule is add 8. So we, once again, you can think of that function machine in your head there. And 1 goes in, we add 8 to it, and out comes 9. Okay. Next we have 2 goes in, our rule is add 8, and out comes 10. Now when we have the output and we need to find out the input, we need to think in our head that a number went in, added to it we have 8, and out comes 11. So what you're going to think is what number plus 8 gives you 11, or think of that inverse relationship. What is 11 minus 8? And so you should have 3 as your input. Okay. Then we have 4. 4 goes in. We add 8, and out comes 12. 5 goes in, add 8, and out comes 13. So we're going to write a rule for that. So we're going to say our input, remember I'm just going to use the variable capital I, equals, excuse me, not your input equals, excuse me for that. So you have your input plus you're adding 8 equals your output. Okay, so your input, whatever you put that number in for I, plus 8 is going to equal your output. Okay, next table, the rule is multiply by 5. Okay, so thinking of that machine, 0 goes in, times 5. Some kids sometimes likes to write the rule in between the input and the output. That helps too. And your output is 0. 6 times 5 is 30. 8 times 5 is 40. 9 times 5. If 9 goes in, times it by 5, 45 comes out. All right, now again we have the output, and we need to figure out the input, so we need to think backwards. So a number goes in, times it by 5, and out comes 20. I guess I should maybe be staying consistent here with my variable and not using n for number, but input goes in, you times it by 5, and out comes 20. So in your head you can do two things. You can ask yourself what number times 5 is 20, and know that I is going to equal 4. Or you can use the inverse relationship of multiplication and say 20 divided by 5 is 4. Okay, so thinking backwards. So your equation for that table is input times 5 equals your output. All right, moving on down. These ones get to be a little bit tricky. We don't know what the rule is. That's what we need to find out. So now you need to be investigators, and you need to look at what's happening with your input and your output. Generally what an author is going to do within a math curriculum or a math assignment is they're going to have at least 3 or 2 different ones to look at to make sure that you can compare them and figure out the rule. This is what I mean. All right, so 2 goes in and out comes 8. All right, so 2 to 8. The first thing I'm thinking is it's either plus or it's times. So either addition or multiplication because it's going up. So it's either plus 6 or times 4. Okay, so that's what I'm thinking in my head. So I'm going to look to the next one to help me guide my way. So I have 3 goes to 12. All right, so 3, so I was thinking it was either plus 6 or times 4. So 3 plus 6 is 9, not 12. Okay, 3 times 4 is 12. Oh, times works. Let's just double check down here. Does 4 times 4 equal 16? It does. So my rule then is multiply by 4. Okay, so that's going to be input times 4 equal your output. So I'd be able to figure out 0 goes in, times it by 4, the output is 0. Down here, needing to think backwards, I have my input times 4. It's going to equal 24. I could say in my head, what number times 4 is 24? And say that's 6. Or I can use the inverse and say 24 divided by 4 is 6. And 6 goes there. Right, moving on to the next one. Rule is not known, so I'm going to look at some input and outputs that have already been put in for me and see if I can figure out the rule. So I have 7 to 14. All right, so it's going up. When it comes out of that function machine, it's getting bigger, so it's either addition or multiplication. So if it's addition, it's plus 7. If it's multiplication, it's times 2. All right, let's look at 15. 15 to 22. Well, 15 plus 7, that's 22. But let's just check the next one. What's 15 times 2? That's 30. So I don't think it can be it. Let's just double check with the next one. I have 11 to get to 18. 11 plus 7 is 18. And 11 times 2 is 22. So it must be add 7. Right? So I'm going to solve it now. 2 goes in. I'm adding 7. I should have 9. Thinking backwards now, I have my input plus 7 equals 10. So I can say what number plus 7 is 10, and say that input is 3, or use the inverse and say 10 minus 7, and my input should be 3. Okay, so you have input plus 7 equals your output. All right. So function machines in the real world and how they work with equations, we have, they can determine things that are happening in everyday life. And of course, we're still using a variable, which is that letter to represent an unknown number to help us solve these input situations. Okay. So let's look at the first one. Write the rule in words and as an equation. All right. So the first one, what we have is number of days, D, and we have a late fee, F. Okay, so number of days late and then late fee, kind of like a movie. All right, so you have 1 day late, it's going to cost you 10 cents. 2 days late, it's going to cost you 20 cents. 3 days late, you're going to pay 30 cents, and so on and so forth. So for every day that you are late, you have to pay a 10-cent fee. So for that first one, a late fee equals days times 10 cents. So a late fee equals your days times 10 cents. Okay. So what would that equation look like? It says late fee, we're going to use a variable f equals your number of days times 10. So 10 times days. All right. So if we knew the days, we would say that times 10. So if we got down here to 6, we're 6 days late. Oh, goodness. We're going to put that into the equation. Say 10 times 6, and that's going to equal our fee. And our fee then should equal 60 cents. Okay, looking at another one. Still going to write the rule in words and as an equation and then complete the table. So the next one is we have bicycles, B, and wheels. Okay, so it gives us 1 bicycle, we have 2 wheels. 3 bicycles, we have 6 wheels. 5 bicycles, we have 10 wheels. All right. So the number of bicycles, or the number of wheels equals the bicycles times 2. Okay, so number, we can figure out how many wheels, number of wheels equals bicycles, times 2. So they have a couple here for us to solve and to take a look at. So we have 1 bike. Oh, let's figure out the equation, I'm sorry. So what you're going to do to figure out your wheels is take 2 and multiply it by how many bicycles you have. Okay, so if we have 1 bike, we have 2 wheels because our wheels are going to equal 2 times the 1 bike, so we have 2 wheels. Okay. So now we have 4 wheels. So we have 4 wheels equals 2 times bicycles. So we need to figure out how many bicycles. So we could say to ourselves, what number times 2 gives us 4? Or we can use the inverse and say 4 divided by 2 is going to give us the number of bikes. Okay, so we should have 2 bikes. Now we know the input. We know that we have 4 bicycles. So 4 times 2. We have our number of wheels we're trying to figure out. So we're taking 2 times 4, and we should end up with 8 wheels. Okay, so we're going to be working a lot on those together in the classroom, continuing on even with these last 3 here, getting an understanding of making that equation and then how that rule works with your input and your output. Have a good night, and I will see you tomorrow.